Welcome back to the show. My name is Conspiracy. Science is on assignment this week. Since science isn't here for this episode, we're going to lean really heavy into the conspiracy end of the spectrum in this episode. Mostly because I don't have a PhD in quantum mechanics, nor have I ever worked or had an internship at CERN or any other physics lab for that matter. What I do have is an active curiosity about the unknown and the unexplainable. I search for answers to questions that haven't been asked yet. This week on Science vs. Conspiracy, we will try to understand the noise of the universe and see if there's a hidden message inside the static over coffee. We'll be right back. Mozart once said, "It's more important to listen to the space between the notes than the notes being played. That's where the magic happens." I'm paraphrasing, but you get the idea. The absence of sound defines the notes that are being played. Music and speech would be vastly different if these pauses were not present. We wouldn't know where one thought ends and another begins. But to me, when it comes to listening to the static and noise of the universe, these rules don't apply. Mainly, probably because we don't understand the language of the static. It's currently up for debate whether or not the Big Bang actually happened. Whatever it was that sparked what we refer to as reality, information has been flying through space and time waiting to be heard. Yet, to this day, we have not detected anything other than noise. Any artificial signal that has been found has been explained away as being terrestrial or naturally occurring, for example, quasars or black holes. But are other civilizations out there in the cosmos trying to communicate with us? Let's find out. There was one signal in particular that got the attention of astronomers on August 15th, 1977. What is now referred to as the WOW signal, a strong narrowband radio signal, was detected by the Ohio State University's Big Ear Radio Telescope. The signal was observed for a full 72 seconds. Unfortunately, 72 seconds is the amount of time that the radio telescope is pointed in any one direction because of how the Earth rotates. The signal was captured at a frequency shared by hydrogen of 1420.3556 MHz. Because it shares the frequency of hydrogen, it makes it ideal for transmitting information across vast distances throughout the galaxy. The signal was unlike any other signal detected prior or since. The signal apparently originated in the constellation of Sagittarius. The closest known star is Tau Sagittarii. This star is roughly 122 light-years away from Earth. The signature of the narrowband signal starts off low, gradually reaching its peak at 36 seconds, before slowly easing back down for the remainder 36 seconds. Since the detection of the WOW signal, astronomers have been listening for the same narrowband pattern to re-emerge. Okay, so it's my understanding, and bear with me for a second, the reason why we can't detect old TV or radio signals from the past is because of the way the signal was originally designed. Once transmitted, the signal bounces around the Earth 3 or 4 times before becoming too weak to be detected. Therefore, we can't listen and watch old TV shows from decades past. Signals from space travel much the same way, however, they're much stronger. So my question is, since the universe is expanding, Earth is in a different location relative to the universe than it was in 1977. The WOW signal would have continued traveling through space at a rate of about 10 kilometers per second. Why can't we make calculations on where the Earth was located relative to the universe at the precise moment back in 1977 when the signal was detected? That way we could track the signal's location and point our telescopes in that direction. However, some astronomers aren't convinced that the WOW signal was even extraterrestrial. Some astronomers have recently suggested that the WOW signal was in fact a comet that was passing through the vicinity where the signal was originally detected. Others remain unconvinced. Even if we were to detect the signal again, how would we even translate it? If this was just one signal, there might be more transmissions that have gone undetected in the static. Maybe we need to listen to different patterns. The silence in between the static. Like Mozart said, listen to the silence in between the notes. Or in this case, the static. I go back to the universe being some sort of computer program that is made up of mathematical equations. As far as we know, there is no true randomness in the universe. Every sequence will repeat itself eventually. I talked about this in another episode, and I'll leave a link. If we go on this assumption, then an alien civilization that has been able to reach or pass the Great Filter would know and understand the nature of reality. Having this knowledge would allow an advanced civilization to move scientific discoveries in a different direction than our own. Understanding the complexities of what appears to be random noise would be key to this technology. The message would appear to be noise, but hidden in the pauses and silence. Between the static, a message can be found. I don't know, what do you guys think? Is there a message hidden in the noise? Are we looking in the wrong spot? Should we be listening more closely to the noise and the static? Or, I guess, in between the noise and the static? I'm going to leave it here this week. My name is Conspiracy, and remember, being paranoid is smart. We'll see you next time. This week's episode of Science vs. Conspiracy over coffee was produced by Lethologica. Research and writing was done by Bob Homer and Jennifer Timer.